Hello, I'm Debbie Wagner, Regional Mathematics Content Specialist with the Kentucky Department of Education. In addition to the grade level content in the Kentucky Core Academic Standards, there are 8 standards for mathematical practices that teachers must intentionally implement from kindergarten all the way through 12th grade. The purpose of this podcast is to help teachers better understand ways to effectively implement the first standard for mathematical practice, which is to make sense of problems and persevere in solving them within a primary math class. Michelle Sturgeon is a 2nd grade teacher at Paris Elementary in the Paris Independent School District and a teacher leader in the Central Kentucky Educational Cooperative Math Network. She encourages her students to use multiple strategies and representations to solve problems in her classroom. Today, her students are making sense of problems with multi-digit subtraction. She asks her students to solve the problems using at least 2 strategies, showing representations for each.
So I want to know, how much money do we have left for a field trip? And is there one way to solve this problem? Is there just one way? If you think of just one way to solve the problem, I want you to put one finger in the air. If you can think about, you know what, I'm going to solve it a different way, put 2 fingers in the air if you can think of 2 ways. Put your hand on your head if you can tell me a strategy that you're going to use. What are you going to try, Haley?
Place value.
You're going to use some place value pieces? All right. What's a way that you're going to try, Gabby?
Algorithm.
You're going to use the algorithm? All right. Who has a different way that they're going to try? Dylan, what are you going to try?
Algorithm.
You're going to use the algorithm also? What are you going to try, Katie? You're going to try and explain it with words? Good. Hands down. In the center of the room, there are lots of different things that you can use. There's some dry erase boards and markers. There's some bead boards. There's some arrow cards. And there's some place value pieces. So you're welcome to get up once you get your paper and whatever manipulatives you want to use, and I'm going to be around to have discussions with you. If you finish your 2 ways, find a partner that you can talk to about, or you can flip it over the back and show me, look, a 3rd way and a 4th way. Right?
What are you doing? The algorithm.
What else are you doing?
The sticks and bundles. What are you doing?
I'm doing algorithm and place value pieces.
What are you doing, Caitlin?
I'm doing an algorithm and an open number. Good job.
Okay, and what have you drawn on your whiteboard?
127.
127. Okay, and so now you have to do what? So what at
127?
45.
Subtract 45. So how do you do that?
You just take 5 ones away. 1, 2, 3. That leaves 2. That leaves 2. And you gotta take, and then you gotta put 12 tens.
Why do you have to do 12 tens?
Because you gotta regroup.
What do you have to regroup?
100.
All right. Well, now I have a different problem I want you to solve, and it's kind of the same concept. But remember, right after we did our Tasty Treats Cookie Company, the 1st graders downstairs had thought our business idea was so good that they started the Valentine Grams. Right? So let's say that the 1st grade made $392 at their Valentine company. But then they had to pay Miss Crane back money for the candy and the tape and the advertising. And they had to pay her back $56 startup fees. And so now I want to know, how much does the 1st grade have left for their field trip? So then,
Okay, so tell me the problem again.
392 minus 56.
Minus 56. So does the 56, does that have to do with the hops that you did? Okay, so tell me how the 56 relates to the kind of hops you did.
The big hops are the 10s, and 5 10s make 50, and the small hops make ones, and we add those up, and that makes 6 ones.
And it makes how much?
6 ones.
6
I took away. Oh,
Your big hops, what were those?
the 10s, and then I took away the 1.
Okay, so when you took away the 10s, how much where were you then?
And 342.
342. So 392, and then you take away 10 5 times, and that gives you 342. Okay, so you're at 342, and now you have to take away how much?
6 ones.
Okay, so tell me what you did there.
I went to the 1, and I took away 1, so I got 341, and then I got 340, and I had to take away the hundreds, and I got 39, and then I got 38, 37, 36.
Okay. What can you do to create a classroom environment that encourages and supports problem solving? What does group problem solving look like and sound like in your classroom?
I think to encourage problem solving, we do a lot of talking about what's happening in our mind, and I tell the kids it's not about the answer, it's about what's happening in your mind and how you get there. And so I hope that I've created an environment where they feel comfortable sharing their answers, and we do a lot of share outs where I record their answers, but I never give any indication initially as to if that is right or that is wrong. We just get different ideas, and then I see them piggybacking on each other and kind of thinking through and changing their answers and minds when they realize what they're saying is not correct, and then we work through it as a group. So how many's here?
10.
There's 10 on each one. Good. So you have how many hundred right there?
300.
300, and then count with me.
10, 20, 30, 40, 50, 60, 70, 80, 90,
Count.
90, 92.
92. Yeah. Are we using these beads?
No.
No, we're totally ignoring them, aren't we? All right. So 392. And how much money did they have to pay?
We've all heard of Vygotsky's zone of proximal development, and what that's defined as the difference between what a learner can do with help and what he or she can do without help. So what are some of the conditions that teachers have to consider when they're allowing that productive struggle and making sure that you keep in the kids' zone?
You have to know your students, and you have to know where they are mathematically with their thinking. You have to know what kind of scaffolding you need to give them. And it's always interesting to come upon them having a conversation with another student and not really let them know that you're there, just because then you get to see a true understanding of when they don't have that support, if they fully, deeply understand that, or even when they share out. Even when we share out in the whole class, I get to see if they have a concrete understanding of what's happening or they still need those guiding questions. And so it's important to let them have that struggle when they're working through the problem, because I think that's where you get into your rigorous curriculum and their understanding. But it's also important not to let them struggle there too much, and to ask the right questions, and not to ask leading questions, but ones that help them formulate their own understanding.
This afternoon, when your class was working, after they had finished individually doing some things with groups, they came up and you had them kind of share out in a whole class discussion. Why do you think having them share out in that whole class discussion is a good idea?
Well, it lets them take ownership of their learning. And it also, talking to me or talking to a peer is one thing, but being able to have those skills to talk in front of a class, and also to have ownership and be proud of their work and share that. And also, we find that some of the people that volunteer haven't actually, their thought process hasn't gone through the whole problem, and so it's just another opportunity for us to refine their skills and to help lead them on the right track for finding that answer. They also get in that opportunity. Maybe they've tried to answer it 2 ways or 3 ways, but maybe the person that's sharing has a master of a different way, and so that helps the other student learn from that child and introduce different strategies that they can use.
Establishing an environment that supports cooperative problem solving will allow students to develop, practice, and apply procedural practices as well as thinking and reasoning skills to the problems that they solve. Problem solving in mathematics offers opportunities for students to solve problems in ways that make sense to them, to talk about and represent the mathematics, to work with a partner or small group, to realize that the process of solving a problem is often just as important as the solution, to apply previously learned concepts and procedures to new situations, to learn to be patient with themselves, and to persevere when the solution is not immediately evident.